easy day yesterday, right, with the activity and you finishing with lots of time. So I'm going to get you to fasten your mathematical seatbelts because we're doing 2 lessons. Yep. Vertical and horizontal asymptotes. Okay? Yes, you've been studying these in 30-1. However, the big difference between 30-1 and calculus with graphing is what? No graphing calculator. We have to use our noggins. Hooray. Okay. So, let's talk about vertical asymptotes, right? It's very easy to see when we have a vertical asymptote because it results when we have a rational expression. What is a rational expression? A ratio, or another word for ratio is fraction, right? When x is on the denominator. This is fun stuff. So it's really easy to see when we have a vertical asymptote. But what we're going to learn how to do today is how do I know what it's approaching on the left and the right side of the asymptote? Is it approaching positive infinity or negative infinity? And guess what we have to use to see what concept? Yes, we use limits when we want to know what it's approaching. Approaching from the left, approaching from the right. It's a ridiculous thing. Okay, so let's write some notes. A function y equals f of x has a vertical asymptote at x equals a when the limit as x approaches a of our function equals positive infinity or negative infinity. So I have all these notes here. That is, as x approaches a from both sides, f of x becomes arbitrarily big positive number, as big as we want. I'm going to write it down. That is, as x approaches a from both sides, f of x, or our y value, becomes arbitrarily big number. As big as we want to think of it. Okay? Or limit as x approaches a for our function equals negative infinity. So as we get closer and closer to a from both sides, the number gets arbitrarily really big. Okay, that's a vertical asymptote. I'm not going to write this all down again. Okay. You can have a vertical asymptote if it's just one side as well. It doesn't have to be from both sides, so we'll look at that. But what we want to do is notice when we have an asymptote and then see what it approaches. That's our goal today. To find the vertical asymptote of a rational function, we find what the values of we find the values of x for where the denominator is what? Is 0. I love the word denominator. Denominator. So strong of a word. Okay, and then we're going to complete the limits. Now guess what? On your test, when you're solving for, when we actually find a vertical asymptote, what you need to find is actually what does it approach on each side of that asymptote. Is it approaching positive or is it approaching negative infinity? Yes. Pardon me? Yes, you do have to write the limit, and you have to write, and you have to do from the left side, and you have to do from the right side. I'm going to be very clear, and I'm going to tell you, a bunch of you will be lazy and try and not write it, and then you'll lose marks. Okay, this is very important. Okay, you can have just some pictures. You can have one-sided limits, or sorry, one-sided infinite limits. So you can have a vertical asymptote approaching from just the left or just the right. So yeah, fun pictures. Next page. So let's review what we did in limits. When we approach something from the left side, If we wanted to approach it from the left side, we think of the left side of 2. Give me a number left of 2. 1. Okay, so yeah, sure. Let's start a little closer to 2. 1.9. Okay, let's start with 1.9. So plugging in 1.9. 1.9 minus 4 divided by 1.9 minus 2. Okay, is 21. I guess you're going to have a guess. 1.99 we're going to plug in now. 1.99 minus 4 divided by 1.99 minus 2. It's going to give you 201. Do you want to take a guess what happens when you plug in 1.999? 2001. Cool, hey? All right, well, I think it's cool. So what is it approaching? Positive infinity. Now we could also use a little bit of our logic here. Okay, so how can I use logic? Well, if I know I'm subbing in 2 from the left, okay, 1.999, what's going to happen is 1.299 minus 4 is going to give me a negative number. Agreed? Okay, 1.999999999 minus 2, is that going to be a really small negative or a really small positive? A very, very small negative. And when I say small negative, okay, there's a difference between a negative and a small negative. We're talking really small. So small that it's approaching 0. Okay? So a negative over a negative, right away, that tells me that's going to become a positive. And if you have a number over a very, 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 very small number, it's going to be very big, positive infinity. Yes. Because I'm plugging in 1.999, 1.999 minus 4 will be a negative. Yeah, and then 1 point, because it's on the left. So the next guy. Again, you could use a chart. So give me a number on the right of 3. Let's start with 3.1. Okay, so plugging that into my calculator, 3.1 plus bracket 2 minus 3.1 divided by bracket 3 minus 3.1. Okay, 14.1. Oh, yeah, thank you. Thank you. There we go. Is that better? Did you get negative 7.9? Thank you. That means that this is correct. Okay, so let's go closer. 3.01. Second enter. And let's insert a 0 here. And insert a 0 there. And a 0 there. Okay, negative 97.99. Okay, we can keep going. Do you want to keep going? Or do you get the point? What's going to happen? Yeah? You should always do the test for both sides. Because you can have one side going positive. Yeah, yeah. Yeah. Yes. Yes. Yeah. Exactly. Yeah. Bingo. So that would equal negative infinity. Now, I'm also going to, let's use logic here too. Okay? So logic says, if I put in a number really close to 3, approaching 3 from the right, so like 3.000000001, I'm going to have 3 plus or a positive plus, we know that it's going to be positive or negative infinity. When you add 3 to infinity, will it change the number? No, or if you subtract, like it's not. But so we can logically work our way through this as well. So we're going to have 3.00001, so it's a positive number, plus, always where we want to see is what is going to be a small positive or negative here. This rational expression is really going to affect us. So 2 minus 3.0001, would that be a positive or a negative? A negative. And it's only a small negative if it's like approaching 0. So 3.00001 minus 3, is that going to be a positive or a negative? A small positive. Okay? And so this part, we get a positive number. This plus is kind of looking like a positive. I don't know. Okay, so here you get a positive number plus negative infinity, would still be, well, this is like 3, right? Remember this was 3? Pretty close to 3. You can also think of it that way. 3 minus negative infinity, is it still going to be negative infinity? Yeah, it would still be. So it's going to approach negative infinity. Okay, so you can logically work your way through it, or you can actually plug it in and find out yourself. Okay, do a numerical evaluation. Find the and sketch near the asymptote. So here, where would we have an asymptote? When x is equal to 6, so vertical asymptote at x equals 6. So we need to do 2 limits for each vertical asymptote. Okay, why do we have to do two limits? Left and right, because can you have one that approaches up and one that's down? Yes, you can. Never. Okay, so how do we write this? This is how we write it. The limit as x approaches 6 from that, which one do you want to do first? Knock yourself out. Left? Okay. And you could either write f of x, if you like. You have to write your function here. So you could write f of x, or you can write 3 over x minus 6 squared. Okay? So from the left side of 6, what kind of numbers are the left of 6? 5.999. So I'm going to have a positive 3, so a positive, over, if I have 5.999 minus 6, what's that? Small what? Negative. But what are we doing to our small negative? We're squaring it, and so we're going to approach what? Positive infinity. Didn't even have to plug it into my calculator. Could you? Sure can. If you want to solve that numerically, 3 over 5.99, throw in some extra 9s in there just to be safe, minus 6 squared, positive infinity. Okay. 3 times 10, well. Okay, limit, now do right of our function. The function's 3 over x minus 6 squared. So 3 is always positive, because we want to know our sign. Really is what we want, right? We know we have to figure out if it's positive or if it's negative infinity. 6 from the right, give me a number that's rated 6. 6.00001 minus 6 would give you a small positive. We square a small positive, still positive, which approaches positive infinity. So what's happening here? Our asymptote is at 6. And on both sides, it's approaching positive infinity. We don't know, we're just saying, okay, generally, what does it look like? Around there. So we're going to use this when we sketch. Fun, hey? No? How do I figure out my asymptotes here? Factor. We can do that really quickly, right? x plus 3x plus 1. How many limits am I going to have to do? 4. Why? Because we have a vertical asymptote at x equals -1 and -3. Okay. We're almost done this lesson, right? So 2 lessons won't be bad today. Limit as x approaches, let's start -1, is that okay? And we have to do one from the left. And if you want, you could just write f of x. Okay, but you have to say what limit you're evaluating. I've seen so many times just the limit equals. Limit of what? What are we approaching? For which function? And then write. Okay, so you could plug in. I'm going to use my head instead of calculator because I just always think that's superior to calculators. I'm a little biased. Okay, so you have a number 6. 6 is not going to affect the sign. When I plug in -1, I'm going to have a negative squared, right? -1 squared. Oh, cube. That's important. That's very important. Over, all right, -1 to the left of -1 would be -1.01, say. Plus 3 would just be positive. Okay, -1.00001 plus 1. Is that a small negative or small positive? Small negative. Okay, so negative cubed, will that still be negative? Yeah. Over a small negative, it's going to approach positive infinity. Is it faster in your calculator? But just because your calculator is faster, so you plugged in like -6, -1.0001, because you just need sign, right? Okay, but if this is a test, what did I do here? Shoot. Yeah, I should be more specific. Okay, and then negative. Okay, you can plug it in. I don't really want to right now. Okay, thanks. All right, from the right, so we'd still have negative from the right would be -0.999. Cubed is still a negative cubed. All over. -0.9 plus 3 would be a positive. And, -0.999 plus 1. Small positive. So what's the sign going to be here? Why is the small positive important in this? That's what's actually making it approach infinity, right? Because this is basically like getting closer and closer to 0, right? So when you have a number over a very small number, it gives you an enormous number. Okay, so that approaches negative infinity. Do we agree? Can you try the other 2 on your own without your calculator? So the limit as x approaches -3 from the left of f of x, and the limit as x approaches -3 from the right. See if you can figure that out without a calculator. Just the tools in your head. -3 from the left is -3.1 approximately. So you're going to have a negative cubed, right, when we sub in x, negative cubed over. Hey guys, if this was a negative 6, would I have to write that negative out? Would I have to include that? Yeah. So I could write positive in front, but we're trying to figure out sign here. Okay, negative 3.1 plus 3 is going to give you small negative and then a negative. So you should have had, we really have negative, 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 or negative infinity. And then from the right, so that's like, oops, I forgot my negative there. Uh-oh. Negative 2.99 cubed is still a negative cubed. All over. Negative 2.99 plus 3 is a small positive. Times negative 2.99 plus 1 will be a negative, which results in positive infinity. Okay, your rough sketch. We have asymptotes at, actually, let's change this. Negative 1 and negative 3. Draw your vertical lines. We're just doing a rough sketch around the asymptotes. So from the left of negative 1 was positive infinity. Right of negative 1 was negative infinity. Negative 3 from the left is negative infinity. And then positive infinity when approaching from the right. So it's going to look something like that, generally speaking. Okay, did we find out zeros or critical values or increase, decrease? No. What we just did is technically just sketch what it looks like around the asymptotes. Okay, that's the first part done. Yes? There might be. Right, yeah, okay. What do you mean? Well, let's look at some examples here. Like to have a better picture of the graph, you need to find your zeros, you need to find all that stuff, right? To really get a good picture, increase, decrease, concave up, concave down, and that will tell you how the ends of the graph kind of look. Okay. Wait, keep going. Okay, so for this portion, yes, can you write this down underneath here? Page 212, numbers 1, and then 2 and 3 are left column. Okay, does this make sense? 2 left column and 3 left column. Does that make sense? Because we can't use our graphing calculators. Do machines make things faster? Often, yes. Okay, horizontal, which you've talked about in 30-1, and maybe you've already done them. Okay, so finite horizontal asymptotes. I knew I shouldn't start talking about machines. A function y equals f of x has a horizontal asymptote at y equals L when the limit as x approaches infinity for a function equals some number. Okay, so as we approach infinity or negative infinity, our y value approaches some number L. So that is, as x approaches infinity, our y gets closer and closer to some finite value L. My negative infinity looks horrible there. Please don't judge it too much. If you want, you can 215 of text. Right? Sorry, whatever. Okay, if you want some pictures of different... It's on the test. No, it's on the test. It will be on the test, though. Guys, we just need to do a quick review of infinite limits, right? We did this in limits. It's a review, so this should go fast. Fast, fast. Comparing the degree on top to the degree on bottom. Oh, good. So we can go really fast. So just the limit as x approaches infinity for 1 over x the r equals what? So if we have 1 over a really large number, what will approach? 0. So we're using that concept, basically. And what if it was negative infinity? Would it still approach 0? 1 over a really, really large negative number. Yes, it would still approach 0. So let's recall a few things. What if our top degree is the same as the bottom degree? The coefficients of highest degree. Let's highlight that. So in this case, are the coefficients on the top equal to that of the bottom? Yeah. What are the coefficients of the highest degree? 9 and 2. So it approaches 9 over 2. And if we write it as an equation, what would it be? If it's horizontal, y equals 9 over 2 would be the equation of the horizontal asymptote. Yeah. If it was a horizontal asymptote. Okay, next guy. Now, what do we do if the top degree is less than the bottom degree? What would it approach? Approaches 0. Okay, remember, just a really side note, remember we used to divide everybody by that highest degree. You can go back to that lesson of limits approaching infinity if you want to go through the theory of this more, but you just covered it in 30-1, so we'll just keep going. Okay, so this would approach 0 because the degree on top is less than the bottom. Turn the page. All right, what do we do if the top degree is greater than the bottom? It's infinity. Plus or minus infinity. Okay, in this case, whoops, our higher 20 over 160, right, those are both positive. Our leading coefficient is a positive. So this is going to approach positive infinity because the degree on top is greater than the bottom. Okay. Yeah. In For this one, it would be positive because it's the leading coefficient is positive. So there are 4 possibilities for type B. So if we approach, and that's the example above, when we approach positive or negative infinity, so we can have our limit as x approaches positive infinity for our function, it can approach less infinity. As x approaches positive infinity, y approaches positive infinity. As x approaches positive infinity, y can approach, what's y approaching here? Negative infinity. We have a case where if we look as x approaches negative infinity, what happens to what's our y approaching here? Positive infinity. Or the limit as x approaches negative infinity, negative infinity. Okay, yeah, we're good. You're all buckled in? Keep going. Okay, so for this example, when x approaches positive infinity, what's our function approaching? Positive infinity. And when x approaches negative infinity, so we go that direction, what is our y value approach? Positive infinity. Does that make sense? Yes, because we're squaring it, right? Negative infinity squared comes out positive. For x cubed, as x approaches positive infinity, what is our y value approach? Positive infinity. And as x approaches negative infinity, what is our y value approach? So to go that direction for x, y is going to go down, negative infinity. Let's skip the next one and go to example 2. Okay, folks, we're going to kind of combine a little bit of what we've learned so far. So asymptotes and intercepts, and then we're going to sketch. So we're not going to do first derivative test. Is this like a test question? Oh, from 3-1, quiz question you just had? Or, oh, well, that's nice when things are like actually intersecting the worlds. Okay, so where do you want to start? Let's start with intercepts. Which one do you want to do first? All these choices in life. Vertical. Y. Yes. Okay, so intercept. So y-intercept, we set x to 0. 0 over 0 plus 2 squared is 0. So that would be the point 0, 0. X-intercept, we set it's also 0, 0. Yeah, we set y to 0, and we're going to get x equals to 0. So that's our one intercept. You could show that if you want, right? We could show 0 equals x over x plus 2 squared. So when you want your function to equal 0, it's really when is your numerator equal to 0, because we don't want when it's undefined. So what would make our numerator equal to 0? X equals 0. So we have one intercept, 0, 0. It's my x and my y. Okay, nope, that's that. Okay, asymptotes. Oh, yeah, that's good. Thank you. Thanks, Sean. Okay, so there's actually 3 types of asymptotes. We've learned about 2 of them today. Well, you already know about them, but which one would you like to start with? Vertical. Okay. Vertical asymptote at where? How do we tell if we have a vertical asymptote? What would make our denominator equal to 0? Negative 2. So at x equals negative 2. How many limits do we have to show then? There's one asymptote. 2 of them. We need to approach -2 from the left and from the right. You have to show this. Yep. Okay, and then you can either write in the equation or you can write f of x equals whatever your heart desires. I'm not going to neglect you of that. Okay, so -2 from the left is -2.1, say. So the numerator would be a negative all over -2.1 plus 2, small negative, but what are we doing to our small negative? We're squaring it, so it's going to approach -infinity, because a negative over anything squared becomes positive, so negative over positive is negative. Okay, -2 from the right is like -1.9. So -1.9 is a negative all over. -1.9 plus 2 becomes a small what? Positive, but what are we doing to it? Well, I guess it doesn't matter. It's already positive, but we are squaring it. So it's going to approach -infinity, okay? If you skip this middle step here, that's okay. So if in your work you wrote the limit as x approaches -2 from the left, f of x equals -infinity. Okay, do you know what I mean by if you skip the middle step? Give me a second. Okay, if you skip that part there, okay? Whoa, no, not that cool. Okay. So that part you can skip and then just write equals -infinity to plug it into your calculator. That is good. Okay, but you do need to write that. Huh? The horizontal asymptotes on page. Horizontal asymptotes, and the same goes for oblique or slant asymptotes, which we'll look at next couple days, next week. You can cross them. We're just looking at what as we approach infinity, positive or negative infinity. So yes, we can cross the asymptote. You can touch this asymptote, okay? But as we approach infinity, we can't. Okay, it's just short term. Long term, no. I don't know how to think of it. So yeah, you've talked about that in 30-1. That's wonderful. Good news. I'm glad you've heard that before. Because before in the old curriculum it wasn't there. And so when they get to calculus, they're like, what? Oh my gosh, mental breakdown. I thought we could never touch an asymptote. We were told we could never touch an asymptote. Well, that's for vertical. Okay? Okay. So let's relax and move on. So moving on, now we need to do horizontal. So first, vertical. 2. How can I look at my function and think, I need to check for horizontal? What tells me that I need to check for horizontal? What kind of function is this? A fraction. It's a fraction. So we need to check our degrees. Okay? If the degree on who's bigger, top or bottom degree? Bottom. If the bottom is greater than the top. So limit as, we need to write this, limit as x approaches infinity for, don't be mad. Well, I guess you could just write it. Yeah, you can just see it. But I'm just going to write it this time, okay? So degree on top is less than the bottom. So it's going to approach 0. So we would say horizontal asymptote at, what's the equation of the line? Y equals 0. Beautiful. Okay, do we need to do anything else? Oh, yeah. Can we do max and min? Let's bring in everything and then call it a day. It is the last question. Wait. No, it's not. Yeah, sorry, I lied. We're going to add in max mins. I know. That is, thank you, Michael. I think you said it, right? No? Is that somebody else? Who is it? First derivative test. So we have to do our first derivative. How do we do our first derivative of a function that looks like x over x plus 2 squared? You used your graphing calculator and probably found the max. Okay, so in 3-1, you would use a graphing calculator and then literally go left bound, right bound, guess, right? Your calculator does it for it, but we're above that, right? We can use our heads. Y prime equals, okay, quotient law, derivative of the top is 1 times the bottom minus, leave the top, x. What's the derivative of the, what do you have to use there? Chain rule. So times, bring down the 2, leave the inside, subtract 1 from my power, and then times by the derivative of the inside. What's the derivative of x plus 2? 1. So let's just leave that all over the bottom squared. So it becomes power 4. Simplifying our numerator. Could we cancel one of the x plus 2's out or factor it out? Yeah, I would want to do that too. Okay, so we could do a few things here, but we do want to simplify this. And we could either just cancel one of the x plus 2's from each term, or another way to think of it is factor out an x plus 2 from the numerator. If I factor out an x plus 2, how many x plus 2's do I have in the first term now? 1, x plus 2 minus this x times 2 becomes 2x. And we factored out that x plus 2, so that's gone. All over x plus 2 to the power 4. So what can we do with the x plus 2's now? Cancel one of them so that we have on the denominator would be x plus 2 cubed. And what is x plus 2x? 2 minus x. Okay, so what are my critical values? Tell me all my critical values. Okay, so on the denominator we have a 2, and the numerator we have numerator is positive 2, denominator is negative 2. So what do we have to do with these values? Test them always. Put them on a number line. What I want you to do with your number lines is label which derivative it is, because we're going to do concavity and points of inflection in the future. And so that's second derivative. So this is our test for the first derivative. This tells your marker which one it is without having to guess. Okay, so negative 3, let's do left. 2 minus negative 3 would give you a positive divided by negative 3 plus 2 would give you a negative cubed is still a negative. So positive divided by negative, negative. 0, 2 minus 0, positive. 2, 0 plus 2, positive. So positive. And 3, 2 minus 3 is going to give you a negative. 3 plus 2 is a positive, so this would be a negative. Now, what I would do for you guys, a common mistake a student will say, oh, I'm so excited, because if I look at my graph, I have decreasing, increasing, decreasing. I must have a min at negative 2, or I must have a min at 2. But what you should label in that so you don't make that mistake is what? Where do we have a vertical asymptote? Choose green. We had it at negative 2. And you can find that when you go actually to try and test that. You'll find out too, but that was a vertical asymptote. So we have actually only a what? A local max at 2. Can I go back up a little bit? Local max at 2, comma, where do you go to figure out how high it goes? The original formula, 2 divided by 2 plus 2 squared. 1/8. Okay, so let's, and on, I'd also ask you probably for state your intervals of increase, state your intervals of decrease, blah, blah, blah. Okay, but tonight, let's sketch this. It's a 10-mark question, usually. Ugh. Yeah, no, you guys will be okay. No. Okay, so we want to draw in our asymptote at -2. We know we're going to have local max at 2. We also have a 0. Where do we cross the axis? 0, 0, 0. And 2 and 1/8 is going to be a max, a local max. Where else do we have an asymptote? At 0. You can cross horizontal asymptote. Come on. Aww. Okay, so let's use yellow. Okay, and also what are we approaching on the left of -2? Positive or negative infinity? We had negative infinity on both sides, right? That was our vertical. We did our limits. We found out negative infinity for both of those. Okay, so this side, is it going to cross asymptote? Why not? No, not because it's an asymptote. You could go up and then down. There's no other x-intercept. And there's no other local max or whatever. Okay, so there's another x-intercept. Yeah, mind blown, right? Okay, this guy approaching 0, this is our local max. And then what happens to him? Is he going to cross 0 again? No, he's just approaching 0. How pretty is that? Now plug that in the calculator and see how well you did without the graphing calculator. It's crazy. Okay, next page. We are almost done. I keep saying that, and then seems like it never ends. This page, I promise. I promise. How are you doing, David? Good? You're alive? Well, okay. Did you want to try this without me? Or do you want to do this together? Okay, together. Limit as x approaches -6 from the right. So easy. -6 from the left. Negative infinity. So what approaches -6 if from both sides it's negative infinity? Negative infinity, right? If left-hand limit equals right-hand limit. Okay, approaching 2 from the right. 2 from the right. Left, right. Positive infinity. 2 from the left. Negative infinity. So what would we say about the limit as x approaches 2 for f of x? Does not exist. What's the limit as x approaches negative infinity? So as x approaches negative infinity. Positive 4? Okay, how about as x approaches positive infinity? -8. That's negative. Done. Okay, homework for this part is page 222, numbers 1 to 5. And that is our double lesson. You did wonderful. We'll have one quiz on both these concepts on Monday.